All right. Hello, everyone. I am Professor Caudill, and today we have found a new website called Fast AI. Fast.ai is the website. So, kind of give you a rundown. So, the book is open source. The software is Fast AI for Pytorch. I haven't checked the license yet. Um, but yeah, I will show you. Here's the book. We can read it free online. So if we wanted to read this chapter one. Okay, so now so this is a book. So it's kind of cool. It's got the book integrated in Jupyter Notebook. So we're pretty experienced with Python and Jupyter Notebook already. So this is nice. And then they have a course. So course is just these tabs, I'm thinking. Not really sure what we would focus on. And then there's the docs itself, the Fast AI docs. The Fast AI is like the actual. So I want to find the GitHub, Fast AI GitHub. What kind of license do they have? Apache 2.0. Okay, so Apache 2.0. I think it's probably fine. And I'm sorry, the Brave browser broke again. Okay. So yeah, as you guys can see, it's got an Apache license. Um, Apache. So it is a free software license compatible with version 3. Okay. So Apache should be fine license as far as the code goes. When was it last updated? 2 days ago, last week, last month. Um, so looks like it's got a pretty active code base. So I think this should be fine. What's going on with my camera? Oh, I probably shouldn't mess with this. I think last time I broke when I did this. Okay. All right. So yeah, I don't know what's going on with the camera. It got really dark at a moment. Um, I shouldn't really be worrying about it though. So yeah, that is. I think we're gonna run with this for a while. This is the home page. This is the textbook. This is chapter 1 of the textbook. And what is this? This is getting started. So I'm not sure where to start. Um, we don't really need to know look at the docs yet. Maybe we start with the textbook and then we do the course. I guess we can try that. So, free course. So, this is for people who want to apply deep learning to practical problems. So this seems to be for us. All right, so this is kind of just advertisement. Hey, I think I listened to this guy on the Lex Friedman podcast once. I think I didn't have any kind of bad, I didn't get any bad vibes from him. So, is this course for me? Hundreds of thousands of students. That doesn't make me feel very, very special, you know? Um, I'm just kidding. All walks of life. Many students told us gold winners. So I'm not really sure. So this is a computer technique to extract and transform data. So myth, lots of math. Truth, just need high school math. Lots of data. We've seen record-breaking results with just 50 items. Lots of expensive meters. You can get what you need for free. All right, so that's kind of cool. I like that kind of going out, really just kind of laying it down. What's myth, what's not. So we will be using software, PyTorch, Fast AI, HF transformers. I've used Hugging Face before. I actually used Hugging Face to deploy the the calculus problem generator. So that way people it would what it would do it would run the notebook as like a web page. Um, so that way you didn't have to like users didn't have to like open up the code and run the script. You just click like a button and it would generate new problems. So I used that for a while. It broke eventually because it's kind of complicated because the most common way to turn Jupyter notebooks into web pages involves like a static, like you run, like it's not expecting the notebook to be ran over and over again, and my generator needed to be run. So every time you would run it again, it would like break the LaTeX display. So it was kind of annoying. I got it to work, and then it got updated. Like the the API I was using got updated, and it broke my script. So um, I could have like just used an older version of that software, but at that point I was like got kind of caught up with other things, so couldn't really spend any more time developing it. Um, but yeah, I shouldn't go on rants like that. Let's get a little bit focused here. So we are trying to build minds that can do things. PyTorch is the fastest growing deep learning library. Okay, so PyTorch is like C language. Fast AI is like Python. C or binary, or what's the other one? There's a something more complex than binary, but less complex than C. It's the term escaping my mind, but I think you get the point. Python language. Okay, so the reason I make this analogy is C is kind of like a lower language. It's not pretty as Python, but Python is not as fast as C. So if you're doing like any hardcore robotics, you're gonna use C. And there's a lot of like, there's a lot of kind of middleman packages that'll convert Python into C for you. But that means like you're kind of it's like it's convenient, but it opens the way for a lot of errors because if you're trying to do actually application specific things, then a third party is not always going to have like your niche in mind. Like for my case, where the API I was using got updated and it broke my niche application. So it's important to like be able to separate them because like if you're doing something very niche, you might need to actually know PyTorch instead of just doing everything on FastAI. Transformers and NLP. Okay. Okay, so what can deep learning do? So natural NLP, that's just like your chat GPT. Classifying, well, not necessarily. Like answering questions is just one way. Speech recognition, finding names. I think finding names or like I want to search pixels on my screen for I want to constantly scan a range of pixels on my monitor for values, so that might be finding names, but or it might be computer vision. It's something in the software, so I'm not sure exactly where. Satellite and drone imagery interpretation. That's pretty cool at it. I mean, it's like of course, but it's like until you say it, you don't really know. But yeah, drone imagery interpretation uses deep learning, computer vision. So that's kind of cool. So medicine, I love using like the medicine analogies when talking about like AI. Um, when it can find anomalies better than the naked human eye, why can't it do other things better? I don't really care about biology that much now, unless it depends on kind of depends on how sophisticated you're getting with it. Image generation, I don't really care about that. Recommendation, don't really care about that. Playing games, yeah, that might be cool. I might try that. Handling objects that are challenging to locate, that might be cool. And logistical forecasting, that might be cool. So, I like, what do I like here? I like computer vision. I like playing games. I like robotics. Um, yeah. Okay. What will you learn after finishing it? I did have like this thought the other day. Often I'll say, I know you guys can read, but as far as like an online education environment, assumptions are dangerous. I want to assume most of my readers can read, most of my viewers can read, but I'm sure, there's some statistic that says, oh, only 80% of the world is fluent in English or something. Not even that. Um, and unless you're using like a video to text to translate this into your native language, then you can't really read it. Um, so I'm not really sure what the best way to go about this is. I want my lectures to be as accessible as possible. I don't know if YouTube will translate my spoken English to another language by itself. I don't know if it has that capability yet. But yeah, let's get back on track. So, how to train models. So, image classification. So, turn your models on web applications point. So, this is Hugging Face. I have experienced making one web application and deploying it. The thing about deploying it is if you have to like actually pay for the compute. So depends on like that's one factor you have to think when you like eventually. I don't know, maybe not early on, but why and how deep learning models work. Okay, so that's important. We definitely want to learn how deep learning models work. The latest deep learning techniques really matter in practice. So what do I want to title this video? Deep learning, just practical deep learning, or deep deep learning getting started? I don't know. Really matter. Okay. So techniques covered, random forests, transfer, anything that I recognize. Not really, not really. So that's okay. Um, how do I get started? To watch the videos, you can click the videos. Videos are all captioned. So while watching the video, click the CC button to turn them on and off. To skim through some lesson notes taken by one of our students. I don't know if I want to watch videos. Video is designed to go through the various chapters of the book. Okay, so they're basically doing what I'm doing. So, I also don't want to watch the videos for that reason. So I want to kind of bring my own point of view into it. So I'm going to abstain from watching the videos. Kaggle notebooks and paper grading. We strongly suggest not using your own computer for training models in this course unless you're very experienced with Linux system administration and handling GPU drivers, CUDA, and so forth. Yeah, we'll just ignore that. I think we can get there. If anything, we can use like a virtual box. We're really concerned. Okay, getting started. Okay. You're going to hit the ground running. In the first 5 minutes, you'll see a complete end-to-end example of training and using a model that's so advanced it was considered cutting edge of research in 2015. Okay. Every lesson includes a lot of hands-on exercises for each one. Okay, Kaggle, what's Kaggle? I've used it before. They have like bounties, I think. Okay. I'm going to sign up real quick. I'm going to blank out this. I'm going to sign in. Continue. I do not want to get emailed. Okay, accept the privacy terms and phone verify. I'm not a robot. Copy in my phone number. Okay, your account is verified. All right. So that's that. So I'm thinking that I do the lesson, I do the textbook first. Do I do the textbook first and then the lessons? Course book. I should do the book. Okay. Okay, so book somewhere. The book is here. Okay, and I'm gonna go here. Okay, can you guys read that? All right. Hope so. So thank you for letting us join on your deep learning journey. Deep learning is for everyone. All right, so this is just trying to convert that graph we saw earlier. So here's where it breaks off. This is where we get into the good stuff, I would say. Um, so nearly all deep learning is based on a single type model. So deep learning equals neural networks. Okay, so let's get into the history of neural networks. If you want to understand deep learning, you need to know what a neural network is. So, 1943, McCulloch, neurophysiologist, Walter Pitts, a logician, teamed up to develop a mathematical model of an artificial neuron. In their paper, Logical Calculus of Ideas Imminent, because of the all or none character of nervous activity, neural events and the relations among them can be treated by means of propositional logic. It is from that behavior that every net can be described in these terms. So I know some will say, some disagree with turning the brain into a mathematical computer. There's good arguments for that. Some will say that um, you know, they kind of trip over their definitions and stuff. But I personally find this a little bit persuasive. So McCulloch realized that a simplified model of a real neuron can be represented using simple addition and thresholding. Thresholding. I don't know what thresholding is shown in. Pitts was very smart, obviously. According to this, very smart. Got to study at Cambridge with Bertrand Russell. He did not take up his invitation. Indeed, throughout his life, did not accept any offers of advanced degrees or positional authority. Most of his famous work is done while he was homeless. Pretty base. Despite his lack of officially recognized position, his work with columns influential, taken up by Rosenblatt. Okay, so let's go ahead and sign some homework here. So I want everyone to read this article, 1943, 10,000 citations. It's pretty wild. 30,000 citations. All right, so um, we're gonna extract the DOI. Is there a DOI link about this article? Yes, here is a DOI link. We're gonna take this DOI link. We're gonna go to Sci-Hub. We're gonna paste it here. And now we have access to the paper without logging in because science should be free. We shouldn't have to give up personal identifying data like a logging in or paying for a scholarly document. We should just have, it should all just be open access. So here's a paper. It is a couple pages, 19 pages. So I'll assign everyone to read this paper. I'm going to download it myself. Who is this? McCullen and Pitts. McCullen and Pitts. Okay, so I will read that later. Okay, so we'll read that paper later. That's our homework for today. Okay, so then there's this guy, Rosenblatt, further developed the artificial neuron, gave it the ability to learn. He worked on building the first device that actually used these principles, the Mark I perceptron. The Mark I perceptron. That's the old one. In the design of an intelligent automaton. Is that a book or? Okay, I want to know if this is a book. Oh, here we go. ResearchGate. View publication. Don't think this is what I want. Frank Rosenblatt. (1958). All right. Can I just unclassified defense documentation center for? Is this it? Right, Rosenblatt. Um, so 4-layer perceptrons, theories, biochemistry, Okay, neural net. It's talking about neural networks. I don't think this is the paper that he's referencing, but it's kind of interesting. It says unclassified. That's pretty cool. Um, and here we have some alien language from outer space. We got alien. Looks like this is a function phi x1 minus phi x2. Absolute value of that is less than or equal to c1 times the absolute value of x1 minus x2. So MJ, so are these neurons? Markov chain, delta time units. Okay. So phi is either 1 or 0 or between. Doesn't say if phi is what kind of number it is. It just kind of says it's between this and that. And then there we have a C1. What is that? Is that a 5? Is that an F? Okay. Oh, that's a zeta. Zeta 1. Um, okay. D gamma. And similarly, alien speak. Finally, alien speak. Alright, so I think I'm probably, this is 200 pages. Okay, so, um, it's not necessarily what we were even looking for. Forbidden. Great. So it's kind of hard to find this guy's actual stuff. Sign. Okay, so it's referenced here, but it's not online. Hmm. Don't think this will work. Yeah. So seems like the Defense Department's pretty interested in this as well. Principles of neurodynamics, perceptron, convergence. What's the title of this? Design. This guy is kind of interesting. Okay, let's try Google Scholar. Um, Has anyone else cited this guy? Rosenblatt. Okay. Let's try his full name. Psychologist Frank Rosenblatt. And what year is it? Probably 19. I think we found the date. We saw the date earlier. So 1958. 1958. 1958. Okay, we have one paper from 1958. What is this? Can I read this PDF? Okay. This is in Russian. Okay. I need to know what they're talking about here, so we're gonna put this in the language model here. No. English. Dude, English. Colon and Pitt's logical neuron is not capable of learning. Well, that's kind of opposite of what the guy was saying in Fast AI. The construction of a neural network has a building block nature. Knowledge, adapting. Okay, so that's kind of interesting. He's saying thanks to Rosenblatt. Oh, so it's saying how he introduced the learning into it. This is kind of like elaborating on what the textbook is saying. Weight coefficients, and threshold coefficients were regarded as variable parameters of the model that are adjusted through the learning process. Okay. Okay, so here's a 1958, but it's named something different. So I wonder if we can find that. While we're searching that, I want to translate this. Probabilistic model. So I want to look at this. Official website of the United States government. Okay. All right, here we go. So here's our next reading assignment. Receptron, a probabilistic model for information storage and organizing the brain. So this is our next let's go ahead and download this. Rosenblatt. So we got McCullen Pitts PDF and Rosenblatt PDF. That's our assigned reading for today. Transmits binary value oscillator called perceptron area. Binary code image is numeric process. Connections between retina and projection area are fixed and non-adaptable. Connections to the second layer and third layer are stochastically generated. Primary goal is to adjust the weight coefficients of the connections and neurons to their response area. Okay. So this is saying the area where the observed object is projected, called the retina. Transmits binary values to a layer called rejection. Okay, so we have retina. We're going to this layer. This is called the projection. Okay. Numerically pre-processed. So these are this is fixed, not adaptable. Connections to the second layer. Okay, then we have a second layer. Is it all connected? Two, okay. So 1, 2, 1, 2, 1, 2, 1, 2. Is that right? So we have 1 to n. So this is 1, 2, n. 1, 2, n. And then we have 4, 1, 1. So you have 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So this is 4, 2, 1. 1, 2, 3, 4. It's got multiple. 1, 2, 3. So this is n to 1. Okay. So this is n, 2, 1. So it doesn't, not necessarily. So it's not necessarily that. So it's 1 to n and then n to 1. And then stochastically. So stochastically means it's like dynamically, right? Randomly determined sequence. It's random. And then a third layer. This is projection layer. This is the association layer. Okay, and then this is, what is that? That is the response area. So that is also one to n, n to 1, n to 1, n to, or is it n to n? The top one is 1 to 1. The second layer, the second node is 1 to 2. Then we have 1 to 4. Okay, so maybe it's n to m, because these can be different numbers. N to m. Okay, so we have 1 to n, n to m, and then n to n to n to k, m to o, m to k. So what's going on here? What is this even? This is like a slideshow from something. Perceptron consists of 2 layers. Perceptron. This is probably what Rosenblatt made. 8 minutes left. Perceptron consists of 2 layers. In the first layer, there are input neurons, which encode the image on the retina of the perceptron binary code. We have a 4x4. How might a 4x4 rid of 3, 4, 5? I meant 5. Take that back. 5x5. 3, 4, 5. Binary encoding. Each one represents a filled square. Each 0 represents an empty square. Okay. I see. So it's saying 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have this is shaded, this is shaded, this is shaded, this is shaded, this is shaded. Okay. So you want to convert this into binary, so that's going to be, you're going to set this equal to okay, so as you can see, equals row 1. So you're just spelling out the rows. So 0, 1, 0, 1, 1, 1, 0, 0. Okay. So you're converting a grid into a series of pixels from the top down. So image on the retina and the binary code. Second layer contains one output neuron. Not sure what this sentence means. Each connection from the ith input neuron by threshold. What symbol is that? Theta. Okay. Theta. About out of time. About out of time. Why does it go from Russian to English? I just noticed that. It's kind of different. Sigmoid function. Pretty cool. Minsky and Papert in their seminal book Perceptron, Threshold Neurons. So does he mention, I think he mentions Minsky. Okay. So literally the next paragraph, he starts talking about perceptrons. This PowerPoint I randomly found also talks about perceptron. So let's just go ahead and say that's our next reading assignment. Perceptron. Does it exist online? Does it exist online? PDF. Perceptron. Here we go. Minsky and Popper, 1969. Download the full PDF. ResearchGate. What is it called? Minsky and Popper. Okay, so that's our. Is this it? Is this it? This is a book review. All right, that's not what I want. Okay, archive.org maybe. Can I download it? No, I cannot download it. Minsky and Seymour. No, I don't want a book review. I want the actual book. Perceptrons. Minsky and Poppert Perceptron. All right, here we go. 42 pages. The Bell System, Bell Labs, maybe. 1965. Visualizing. That's not what I want. Not what I want. Yeah, this is not what I want. I want to read this book, Perceptrons. Maybe I actually have to buy it. It's gonna be annoying. Perceptrons by Marvinsky, open library. Is it open? Can I download it? Nope, I can't. It's not open. Okay, awesome. Perceptrons. It's kind of a cool graph. Yeah, I really can't find this book. So it's kind of annoying. Alright, so I'm probably gonna have to just buy this. Perceptrons, introduction to computational geometry. So yeah, let's go ahead and read that book. So our reading list is the Rosenblatt, the McCullen and Pitts paper, and then the um, Perceptrons by Marvin Minsky. So we got a little bit into the history. So far, I kind of like this book a little bit more than the original book we used. So we're out of time. So we will return after we read these books and papers. So these are going to show that they fail to learn Zor. So if you ever see Zor, that is this sign. It's a plus with a circle on it. So these books will show that using multiple layers allows us to use Zor. Okay, so when I read these books, I'm going to be focusing on Zor and how multiple layers fixes it. All right, so let's pick off next time here. And yes, I will see you guys next video.